All right, good morning. Welcome back to Applications of Calculus 2. I am looking at a volumes of revolution problem where we have to figure out the volume of revolution for this function from 1 to 12. So I'm just going to use my little paper right here and go ahead and deal with this. We'll save it so I can keep this forever. So what we have is we have integral pi r squared. This is for the thing, the dx. Okay, so we're taking bigger and bigger and bigger columns for this thing. If I go back to looking at the 1/3 x plus 1, right, we've got a slope of 1/3. We've got a y-intercept of 1 here. So we're going to have something like this, and we're going from here to like 12, and we're rotating this around. So effectively, we're trying to figure out the volume of a cup, right? So the first thing we have to do, we have to look at this 1/3 x plus 1, and we have to square it. So we have 1/3 x plus 1. There's a little bit of confusion with people putting the x on the bottom rather than on the top. And I tried really careful to make sure that it was a 1/3 times x so that we would be able to see like slope and intercept and be able to figure out coefficient versus if this was a rational function with 1/3x, I would definitely try to write that differently. So it would be like in parentheses or something like that so that you could see that the 1/3 would, the x would be on the bottom or the top. So this one I tried to write it so it was clear that it was on the top. Okay, and then what we have to do is we're going to have to go ahead and square this thing out. So we have 1/3 x plus 1 foiled with 1/3 x plus 1, and we're just going to multiply that out. Okay? I mean, maybe do it in your head, but at the same time, since it's a 1/3, now I'm a little bit afraid of this, a little intimidated because there's fractions. This is going to be 1/9 times x squared. We're going to have this 1/3 and that 1/3. So we're going to have a 2/3. X is still on the top here, plus 1. And then now we're going to go ahead and squared it. Now we're ready to integrate this. So I'm going to go ahead and integrate 1/3 x squared plus 2/3 x, not anything yet, x to the 1 plus 1. We're just going to go ahead and integrate this thing. So we end up with 1/3 x cubed over 3 plus 2/3. We're integrating x, so it's x squared over 2 plus x. All right, so that's how we're going to go ahead and figure that out. There's a couple of things that we're going to do to just, actually, this shouldn't be a 1/3, this should be a 1/9. I wrote it right here and I didn't carry it down for myself. So, ninth, okay, 3 times 3. So we can go ahead and simplify this a little bit. So this is going to be 1/27 x cubed plus this 2 and the 2's are going to cancel. So we're just going to have a 1/3 x squared plus x, and we're running this from 1 to 12. Okay, and if you think about this being in centimeters, 12 centimeters isn't that much. So really what we're talking about is something that's like kind of like a Dixie cup. It was a small cup, okay, that we're ready to deal with. Okay, think about the kind of cup you would give a child to drink champagne out of for a wedding. Not that my parents ever allowed us to do that. Okay. So we have 1/27 times 12 cubed plus 1/3 times 12 squared plus 12. And then we're going to say minus, and I've got 1/27 times 1 cubed plus 1/3 times 1 squared plus 1. Now, for you guys, I said, you know what, I'm going to go ahead and help with the calculator. By the way, this is all times pi by the time we're done here. So I went through and did all of that. I got 127 times 12 cubed. Again, calculators are very helpful for this. After a little bit of arithmetic with the calculator, we got to 64. That was the 12 cubed divided by 27, plus 48. That's 144 divided by 3, plus 12. And then what we're going to do is say minus 127, minus 1/3, minus 1. And there's like a key on my calculator. It looks like A, B, C, like this. This automatically does fractions for you, which is super nice because if you wanted an exact answer, if you wanted to let the fractions deal with it, you don't have to worry about common denominators. You can just go ahead and deal with that. I went through and said, okay, let me start adding up this stuff. So I got 124, and then what am I doing? So we're saying, I think this is minus 37 over 27. So at the end, I ended up with 3311 divided by 27 pi. And if I go ahead and calculate that out with all decimal places, I end up at 385.3. And again, if all of these guys are in centimeters, by the time I'm done, this is going to be centimeters cubed, which everybody in biology will tell you that a centimeter cubed, cubic centimeter, cc, is actually equal to a milliliter. Okay, so that would be the units for this thing. So I hope that was a little bit helpful for how do you do this problem. You have to be really careful with this and try to deal with the with squares and rules of exponents and how all that works. So be careful with it. But if you have to FOIL it out, then go for it and do that. Sometimes it's rules of exponents problems for this. Yeah, so we'll stay with that. I'm going to say thank you very much for watching the video and good luck with everything that we're doing. Okay, thank you.